Good morning, students. Last class we have discussed about screw gauge and vernier calipers. These instruments are used to find to measure the smallest distance. For now, if I want to measure a larger distance like height of a tree, height of a flag post, or height of a tower, height of or distance of moon from the earth, or distance of a planet from the earth. How we can measure these distances? Whether we can measure with the help of screw gauge or vernier calipers, it is impossible. So, to measure the larger distance, we use indirect methods. There are three indirect methods. One is triangulation method, next parallax method, and the last one is radar method. Now we will discuss about triangulation method. How to measure the height of a tall object using a clinometer. First, you place a separate distance away from a tall object. Then measure the distance from the base of the object to the point from your standing. Here I am going to measure the height of the flag post. So first you take a clinometer in your hand and locate the end of the object. Once you located the end of the object through this straw, let the clinometer stay steady. Once it becomes steady, record a reading on the clinometer when the string touches the scale on the clinometer. So here I got an angle of elevation 45 degrees. From right angle triangle, we can calculate, that is tan theta is equal to h by x. Therefore, height is equal to x tan theta. From this, I can able to calculate the height of the flag post. Now, we will find out the height of a tree. Let us consider a tree AB of height h. An observer is standing at C from D at a distance of x. Now, with the help of range finder or clinometer, the observer looks the end of the tree. It makes an angle of elevation theta. Let the theta be equal to 45 degree. Now, I want to find out the value of h. By using trigonometric formulas, I can able to calculate the value of h. Now, if you see this diagram, it looks like a right angle. It looks like a right angle. A, B and C. Here it makes an angle theta. So, this side will be opposite side, this one will be adjacent side, and this one hypotenuse. What is the length of BC here? X. Length of AB? X. What we have to calculate? We want to calculate the value of x. We know this value. So, this x is where opposite. X is adjacent. In trigonometry, opposite by adjacent is nothing but tan theta. It is nothing but tan theta. So tan theta is equal to opposite by adjacent. This opposite is nothing but what? AB. Divided by adjacent is BC. So tan theta is equal to, what is AB here? X. Divided by, what is BC? It is x. I want to find out the value of x. Just interchange. So x is equal to x tan theta. This is a formula to calculate the height of a tree or flag post, tower, so on. If I know the value of x and theta value, I can able to find out the height of a tree. For example, let us consider x is equal to 5 meter. Let x is equal to 5 meter and the angle of elevation theta is equal to 45 degree. Angle of elevation theta is equal to 45 degree. Then what will be the value of x? So x is equal to x. What is the value of x? 5 into tan theta value is 45 degree. So 5 into tan 45 1. So we will be getting it as 5 meter. This 5 meter will represent the height of a tree. Now we will see an example for triangulation method. Problem number given in your textbook. It is example 1.1, page number 13. The problem is, from a point on the ground, the top of a tree is seen to have an angle of elevation 60 degree. The distance between the tree and a point is 50 meter. Calculate the height of the tree. So what is given? From a point on the ground. Let us consider this is the ground. From a point on the ground. Let it be A. The top of a tree is seen. So let us consider this is tree. The top of a tree is seen to have an angle of elevation. To have an angle of elevation 60 degree. Have an angle of elevation 60 degree. The distance between the tree and a point. The distance between tree and a point is 50 meter. Is 50 meter. Calculate the height of the tree. They ask to find out height of the tree. Now let us consider this is D. This one is C. Now what is given? What is given? Theta. So I can write like this. Angle of elevation. Angle of elevation is equal to, that is angle of elevation theta is equal to 60 degree. Then distance between the tree and a point. So distance that is, I can write it as x, that will be equal to 50 meter. What we have to find? What we have to find? Height of the tree. Height of the tree. Let it be x. So we go for solution. So if you see this triangle ABC, tan 60, that is, we know that the formula x is equal to x tan theta. Otherwise, with the help of that trigonometric formula, we can calculate. So What is this? X. It is in the opposite side. And this one is adjacent side. So I want to know the value of x. So opposite by adjacent is nothing but what? Tan theta. So I can write tan theta is equal to opposite BC by AB. BC by AB. What is tan? What the value of theta? 60 degree. So tan 60 is equal to BC is nothing but what? X. AB is 50. Take this 50 in this side. We'll have X is equal to 50 into tan 60. So 50 into, what is the value of tan 60? Root 3. The value of tan 60 is root 3. So 50 into the value of root 3 is 1.732. Now we multiply this 1.732 into 50. 5 2s are 10, 5 3s are 15, 16, 35, 36, 8. So I can write 86.6 meter. So therefore, height of the tree. Therefore, height of the tree is equal to 86.6 meter. Now we will discuss about parallax method. This parallax method is used to measure the longer distance. For example, the distance of moon from the earth or distance of planet from the earth. You can also find the diameter of the moon by using parallax method. So our scope is how do we measure distance of moon or any planet using parallax method. Next one is how do we measure the diameter of moon or any planet using parallax method. Now, what is parallax? Just we will see an example. Now, you take a pen, just keep it in front of your eyes with respect to background. That means now this blackboard is a background and I am standing like this and viewing this pen. This pen acts as an object now. I am viewing this pen with respect to the background. So what I am doing is just view this object by closing one eye. For example, I close the left eye, through right eye, just to view this object with respect to background. We can see that there is a change in the position of the object. That change will move towards left. Now, you close your right eye and view this object through left eye, keeping or with respect to background, we can see this object moves towards right. This apparent change with respect to background is called as parallax. What is apparent change? Change occurs in that moment. What we can call it as apparent change. Now you see the definition. Apparent change in the position of an object. Position of an object means that is left, moving towards left. The other one is moving towards right. With respect to background. That background is blackboard I told. When the object is seen from two different positions, What are the two different positions? One is left high, the other one is right high. Let us consider this is an object. This left and right are the two observers. The distance between these two observers, what we can call it as basis, and it is given letter B. Now you join this OL and OR, making an angle theta. The distance of OL be x and distance of OR is x. This x is unknown distance that we want to calculate. This is an unknown distance that we are going to calculate. This angle represents parallax angle. Angle represents parallax angle. Now we know that if the object moves far away from this object, from this line, we can see this line in the form of arc. It looks like in the form of arc. It will be like this. It will be in this form. Now I want to find out the angle. So theta is equal to arc length divided by radius. Arc length divided by radius. Here what is the arc length? B. Radius is x. So theta is equal to B by x. I want to find out x. That is the unknown distance. Just interchange. So I can write x is equal to B by theta. X is equal to B by theta. So this B easily we can calculate, and if you know the value of theta, then I can find out the value of x. Determination of distance of moon from the earth. Let us consider this one is earth and this one is moon. Now I want to find out the distance of moon from the center of the earth. Okay. Now C is the center of the earth. A and B are two diametrically opposite surfaces, that is opposite places on the surface of the earth. Now, there are many rays coming from the stars which is at the longest distance and falls on the earth parallelly. Now let us consider two stars, S1 and S2, and these two rays comes and falls on A and B. Now this S1A and S2B, we'll call it as a reference line. Now, with the help of telescope, just stand at the position A and you view the moon, and you will be getting an angle theta1 with reference line. Similarly, you stand on B with the help of telescope, you view the distance of moon, and the angle is theta2. In geometry, we can say S1, A, this is M and C. This one is theta1. This will also be theta1 because of vertically opposite angles. Similarly, if I take this one, C, M, B, S2. If this one is theta2, this will also be theta2 because of vertically opposite angles. So therefore, this angle will be theta1, this angle will be theta2. So overall, this angle will be theta. So therefore, theta is equal to, I can write theta 1 plus theta 2. Now you see this one, M A B. It looks like a sector. Now this AB is in the form of straight line, but here I have given in the form of arc, because if you see the object, that is if the moon is a very long distance, if you leave that object, that is the earth, it will be in the form of arc. Now we know that theta will be equal to arc, that is AB, length of the arc divided by the distance. Here the distance I will give it as AM. Understood? So since theta is very small, I can write AM is approximately equal to this AM distance is approximately equal to CM. So I can write theta is equal to AB by, instead of AM I can write CM. Interchange. So CM is equal to AB by theta. CM is equal to AB by theta. The CM is nothing but distance of moon from the earth. If you know the diameter of the earth, if you know the value of theta, then easily we can calculate the distance of moon from the earth. Now you can see an example problem based on Taylor's method. This example sum, it is given in page number 14. The moon subtends an angle of 1 degree 55 minutes at the base line equal to the diameter of the earth. What is the distance of the moon from the earth? Given radius of the earth is 6.4 into 10 power 6 meter. So the moon subtends an angle of 1 degree 55 minutes at the base line equal to the diameter of the earth. That means this one is the earth, this is the diameter, here we are having moon, this one is earth, we are saying it makes an angle, it subtends an angle, theta, and that value is equal to 1 degree 55 minutes. Let us say this is A, this one is B, O. And radius of the circle, radius of the earth, it is given as 6.4 into 10 power 6. 6.4 into 10 power 6 meter. 6.4 into 10 power 6 meter, it is given. Now what will be the diameter? 2 into radius. 2 into radius will give what? Diameter. So diameter is equal to 2 into 6.4 into 10 power 6 meter. That is equal to 12.8 into 10 power 6 meter. Understood? Now consider the question. What is given? Angle. Theta is equal to 1 degree 55 minutes. Now you must convert it into radian. How to convert? Theta is equal to 1 degree 55 minutes. 1 degree equal to how many minutes? 60 minutes. So 60 plus this 55 will give 115 minutes. Now you convert this minutes into second. So when you are converting minutes into second, multiplied by 60, you are getting 6,900 seconds. So we already calculated 1 second is equal to 4.85 into 10 power minus 6 radian. So from this I can calculate for 6,900 seconds. So for 6,900 seconds how much? So you multiply these two answers, you will be getting 33,465 into 10 power minus 6 radian. So in scientific form, if you write 3 point, that is 10 power minus 6, you take divided by 4, that is Take 4 towards this side. This 3.34 into 10 power minus 2 radian. So this meter I can write it as what? 3.34 into 10 power minus 2 radian. Then what is given? Radius of the earth. So radius of the earth is how much? 6.4 into 10 power 6 meter. So therefore diameter is equal to 12.8 into 10 power 6 meter. Now what you should find? What we must find? Distance of the moon. So we must find the distance. So solution. X is equal to b by theta. What is b? It is nothing but the diameter of the earth. So 12.8 into 10 power 6 meter divided by what is theta? Theta is 3.34 into 10 power minus 2 radian. If I simplify this, I will be getting 3.83 into 10 power 8 meter. This is the distance of the moon. Distance of the moon from the earth is equal to 3.83 into 10 power 8 meter. This clear for you? In your textbook, page number 39, from under 4, numerical problem, question number 4. Jupiter is at a distance of 824.7 million kilometers from the Earth. Its angular diameter is measured to be 35.72 arc range. Calculate the diameter of Jupiter. Now, this is Earth. This one is Jupiter. So Jupiter is at a distance of 824.7 million kilometers from the Earth. So from the Earth, the distance, the distance d is equal to 824.7 million kilometers. Then what is what? Its angular diameter is measured to be. Its angular diameter means this one is called angular diameter. It will be theta. What is given? 35.72 arc range. They are to calculate the diameter of Jupiter. This is the diameter of Jupiter. So they have to find out the diameter of Jupiter. Now, what is given? D. Capital D is what? Distance from Earth to the Jupiter. So distance from Earth to Jupiter is equal to 824.7 million kilometers. Now this million, what is million? Into 10 power 6 kilometers. Then angular diameter, angular diameter theta is equal to 35.72 arc second. What they have to find? diameter of Jupiter. Diameter of Jupiter. So theta is equal to d by capital letter D. So I want to find out small letter d. So d is equal to theta into d. Now d is equal to, what is the value of theta? 35.72 arc second into capital letter D 824.7 into 10 power 6 kilometer. Understood? Now, we know that 1 second is equal to 4.85 into 10 power minus 6 radian. So, we know that 1 second is equal to 4.85 into 10 power minus 6 radian. So, for 1 second, 4.85 into 10 power minus 6 radian. Therefore, 35.72 seconds, how much radian? What we should do is, we must multiply. So, 35.72 into this value. 4.85 into 10 power minus 6. Then this value. 824.7 into 10 power 6. This 10 power minus 6, 10 power 6 will cancel. Then, if I add this, if I multiply this one, 142,872.674. So much kilometer. If I multiply these values, so I will be getting this one. So, when writing it in the form of scientific one, this decimal you must bring it to the first position here. So then how I will get it? 1.428 into 10 power 1, 2, 3, 4, 5. So 10 power 5 kilometers. This is what? Diameter of Jupiter. Therefore, diameter of Jupiter is equal to 1.428 into 10 power 5 kilometers. So I can write, therefore diameter of Jupiter is equal to 1.428 into 10 power 5 kilometers. Here. So today we have discussed about triangulation method and parallax method. Thank you.